It would be a great pleasure to be here with you in person. I wish I could be, but I have to be about 2,000 miles away from you at this particular moment. I will be available to answer questions when the talk is over. As it is, this gives me an opportunity to speak with you for a few minutes, particularly the beginning, to talk about what opening the high frontier really means. I think that we have to understand that at the deepest possible level, opening the high frontier means making possible and ensuring the survival of the human race. And not just the human race, but all of those other species of animals and plants who have grown up with us in this wonderful thin biosphere on the surface of the earth, a place which may be, as far as we know, perhaps even unique in the whole universe. Life is extraordinarily rare, extraordinarily precious, and we have a great duty to preserve it, not necessarily to have it expand to some particular total number of individuals, but to have it spread in a way that will ensure its safety. We know, unfortunately, that we are on a very fragile planet at the present time, with the enormous number of nuclear weapons that there are spread throughout many nations of the world. We're living almost on a time bomb at the present time. These are the most dangerous decades in all of human history. We have the capability to destroy ourselves, and yet we have not yet quite broken free of the limitations of that thin biosphere of the earth. Once we do so, once there are ordinary, living, breathing human beings, along with their plants, their animals, their food crops, and so on, building biospheres of their own, expanding farther and farther away through the solar system, and eventually out to the stars themselves, the human race will be truly unkillable. And I think that at the deepest level, that has to be our motivation. When we look back in history to the earlier waves of colonization that have occurred, the thing that's impressive about them is that it wasn't the rich and the famous who migrated. It was people who felt that in the surroundings they came from, there wasn't enough room for their creativity, their expansion, their freedom, their chance to do their own thing, their chance simply to make a decent living for themselves and to support their families. We know how bad things are now in many parts of the world. The deforestation of almost every part of the tropical jungle is a terrible tragedy which is going on right now and on a time scale of years and decades at most. We know that the pressure to colonize, the pressure to go into new areas, open up new places where people can live is very, very great, always has been. But if we look back at the successful colonizations of the past, and that of the North American continent is, of course, uppermost in our minds, we see that it was largely, although not entirely, young people who came. It was people who had the courage, the guts to go and try something new. It was the people who felt that the situation they came from was, in many cases, intolerable. If we look around us at the world we live in today, a world of increasing crowding, increasing very, very serious problems, we see that some of the same pressures that were there before are there again. There are many people living in the world who feel that they're in places and in situations that are repressive, that don't give them an adequate scope to even make decent livings for their families, certainly not to live in freedom. When we open up the high frontier by building colonies in space and have those colonies extending farther and farther outward in our solar system, there is going to be room for people who want to leave the Earth to go out and to develop their own colonies and to do their own thing. Do their own thing not in a sense of wild abandonment or anything of that sort, because when you ask about the aspirations of people throughout the world today, they're mostly very modest aspirations. A decent living, a chance to live in freedom. Those are the basics. That's the second important thing about opening the high frontier. And I think that in doing so, we're following a history which began really when the first fish came out of the water and became amphibians. The expansion to new ecological ranges is a natural part not just of human history, but of all of the history of life. In opening the high frontier, there are important things which we can do very directly for the Earth itself, for people who are living here in the near future. One of the most important has to do with energy. As you know, there is a very, very close correlation between the amount of energy which is spent by a society and the standard of living of that society. People have tried lots of ways to beat that relationship, but aside from doing all the conservation that we can't do very much about it. It's remarkable how close that correlation is. So the question becomes, how can we provide the amount of energy which a growing set of societies throughout the world really need without destroying the Earth in the course of it? We're not very comfortable about nuclear power. We're certainly not comfortable about burning fossil fuels, because within less than 40 years, the buildup of carbon dioxide in the atmosphere is going to produce a very serious greenhouse effect. And so, where are we going to get the energy which is so necessary for the aspirations of those people, particularly in developing societies on the surface of the Earth? The best answer that I've been able to find after a lot of careful investigation and research is to take that energy from the sun. Sunlight as a source of energy is not very practical if you wait to intercept it until it comes to the surface of the Earth. One thing, the day-night cycle turns it off at least half the time. And second, at least, unless you happen to be in the middle of the Sahara Desert, cloud cover turns it off a lot of the rest of the time. Also, it's a source which changes its direction in the course of the day. Very difficult and awkward to use. But if one intercepts sunlight high above the Earth in a place where it's permanent, in high orbit, and then converts it to some harmless form that retains the energy, the present best choice is low-energy radio waves of a low enough frequency that they can't be damaging to anybody. Transmits that radio wave energy to the surface of the Earth and converts it to ordinary electricity that we can plug into. One has a solution to the energy problems of the world. The fundamental idea that the next ecological range, the next place for the human race to expand to, is in fact colonies in free space itself rather than the surfaces of planets, goes back a long time in human history. The first person who wrote it down in what seems to me to be a coherent and thoughtful and well-reasoned way was Konstantin Tsiolkovsky, who wrote in Russia in the early years of this century. He certainly understood the fundamental idea that if one gets out into free space, one has solar energy as a free and inexhaustible, totally reliable source of energy to power a human civilization. And he also had the fundamental idea that there's a lot more room out there than there is on the surfaces of any of the planets in the solar system. There were, of course, a number of people in between, but then the next one that particularly caught my attention was Dandridge Cole. Dandridge Cole, writing in the 1960s particularly, looked at the possibility of converting asteroids to colonies in space that could be used for human habitation. In the years from 1969 to 1974, I looked at the logic of building habitats in space and realized that from very simple physics it made sense. There's constant sunlight there as a free energy source. There's a lot of room. There are materials in space adequate to build space habitats for thousands of times the present population of the Earth. And one can provide atmospheres, of course, simply by enclosure, rather than by holding an atmosphere in with the very, very weak force of gravity, as we do it on planets. One can provide rotation for a gravity that's of a kind that Dr. Newton taught us about some 400 years ago. All of these things are obvious. They're not complicated physics, but they make logical sense. And when I did my 5 years or so of work on my own, talked about it with other people, finally there came a point where that volume of evidence, that volume of reasoning and logic, was such that it was possible to have it published in a reviewed scientific journal. And that had been my goal. I didn't want to publish the work as science fiction because that would give it completely the wrong cast. This is serious reality of where we're going. So finally in 1974, we did reach the threshold of being able to publish that work in a reviewed scientific journal. Very quickly then, the ideas spread throughout the world, and the general public caught on remarkably quickly. They understood the point of what was being said. It was in those 5 years of independent work that I also learned about the precursors, Tsiolkovsky and Cole, and the fact that they had been through much the same reasoning themselves years earlier than I had. From 1974 to about 1978, a considerable part of the work that was done in the research on opening the high frontier was supported by NASA. And of all of the work that was done, perhaps in terms of volume form, the work of the 1976 NASA Ames summer study on space habitats is among the most important. It was a large group of people, about 55 people, working very intensely over an entire summer, and it drew from scientific and technical and engineering background of a wide variety of very intelligent people. Now, at the same time that NASA very helpfully supported that work and supported some of the intermediate work on what are called electromagnetic mass drivers, accelerators for launching material from the moon, there were also frustrations associated with dealing with the federal government. And those frustrations were especially that the federal government characteristically changes its mind about once a year as to what is the goal and the reason for work that it's supporting. I found finally that with all the goodwill that there was, and there was a great deal, from people within NASA, with all of the good relationships that had been set up, still it was becoming a drain that so much of my time and effort had to be devoted to meshing with the official governmental system as to the reasoning behind the support of the work, whereas I really wanted to concentrate on the work itself. In founding SSI, we decided that we were not going to be a lobbying organization. There were plenty of those already. We were not going to argue and be political about trying to get the federal government to do the job for us. Instead, the funding would come from the people themselves, who were going to benefit from the opening of the high frontier. So, from its founding in 1977, SSI has been supported by the people themselves through the membership campaigns and, very importantly, through the senior associates of SSI. Those are the people who have supported SSI to the level that allows it to fund the specific research programs in science and engineering that have made it so unique and have opened the high frontier as far as it has been opened to the present time, and will, we believe, continue to open it until there is the breakout into the whole new ecological range of the solar system. We need to understand the roles that the individual human beings will play in the opening of the high frontier and the role that the various federal governments will play. And I say various federal governments because, as has happened in high energy physics and a number of other areas, we cannot assume that it will be the U.S. federal government that will be the leader forever in space programs. The dual roles are quite different. Let me illustrate by an extreme example. Perhaps the most extreme example of a federal type of program would be a program with the goal of having some sort of activity on the planet Mars. It's a very, very long-term program, 30 to 40 years. It is not connected with very much in the way of economic justification. A lot of very good science that can be done that way. But it's something that one could not imagine people doing because they're interested in going out and making better lives for themselves or something of that kind, which is the primary rationale of the high frontier. The federal government, or the federal governments of many countries, in doing a series of projects which would at some point result in landing people on the planet Mars and establishing some sort of habitats there, so on, can be doing a great deal that cannot be done by individual people or by the private sector in any form. And that is developing the infrastructure of space vehicles, the technology of long-term habitation in space in very small capsules, very small environments, which is very, very worth doing. We need a fair amount of that in order to provide the infrastructure for the creativity, the ingenuity, the drive of individual people to open up what is to me a much less sterile, much more exciting, much more vibrant, alive kind of space program, which is the space program of the high frontier. The corresponding thing, if one goes back to the American West, was the transcontinental railways. The transcontinental railways could not be done by the settlers who came out and settled Oklahoma and Kansas and places of that kind. They had to be done by a cooperative effort of a lot of private capital that invested in them and the federal government. One big difference was that they did have a very, very strong economic driver behind them. It was expected that the transcontinental railroads were going to be very, very profitable. Now, I believe that the Mars program, a program to go and settle, I won't say settle, it's inappropriate, but to land people on the surface of the planet Mars as one of a number of other goals to look throughout the inner solar system is very worthwhile. It's a very good thing to be doing. It sets a long-term goal for a portion of our space program, the federally funded portion, and the really exciting thing about it is not so much the end point, but those things that can be done very early on. We need, and we do not have at the present time, a vehicle which can go from low Earth orbit to the surface of the moon and back again. We simply don't have it. We had it back in the Apollo days. What we need now is a much more economically effective, totally reusable kind of vehicle that can do that kind of thing. To me, it's very exciting, very positive, that one of the first things one would do in developing a space program for manned exploration of the inner solar system, that one would have to try everything out first on the surface of the moon. One would have to be developing the space vehicles which can make voyages of a few days before one develops space vehicles that can make voyages of years, as is required for going to Mars. Mars is of interest, I think, not only scientifically, but because it's the only other planet in the inner solar system which people can go to in any reasonable way at all. They'd have to be living the same way that they do in space colonies, namely in enclosures, but at least they could go there. There's no place else of which that can be said. It seems to me that one of the critical milestones of the past 20 years has been the appointment and then the work of the National Commission on Space. Important because of the way that ideas formerly thought to be not in the mainstream of space development have now come to be accepted in the course of the thought, the reasoning, the discussion that's gone on. over the past 10 to 15 years. If you look at the report of the National Commission on Space, you'll find some very important things there. One is that in contrast to, let's say, the idea of the Apollo project, it's not a one-shot proposal. We're not proposing that someone go to a particular planet, plant a flag and put some footsteps there and then come home. In fact, very specifically, the Commission's report avoids naming specific goals of that kind, which would be one-shot, almost self-defeating kinds of goals because there wouldn't be any follow-up to them. Instead, it proposes the development gradually of an infrastructure that will make it possible for us to move farther and farther out into space with people. And the other thing that to me is particularly important about the work of the Commission, when you think of the fact that there were 15 of us commissioners representing a wide variety of points of view, a wide variety of philosophical outlooks between, let's say, the most future-oriented and the most conservative, was that 15 people agreed that it would be central to any development of space in the near future that we bootstrap our way out by using non-terrestrial materials at every stage of the way. That was 15 years ago not at all a mainstream idea. Now it is, as a result of the work of the National Commission on Space. And I don't mean that the Commission was spearheading something. What it was doing was collating information, input that came from NASA centers, from individual societies, from individual people, and it's just come to be understood now as a fact of life that the only practical way to go out into space from now on is going to be to use the energy and material resources which are there waiting for us to ease our way. Just as when we came to the North American continent, whether we came 10,000 years ago, as the earliest Americans did, or whether we came a few hundred years ago, as the Western Europeans did, we didn't come carrying everything with us. We came carrying tools, and we used the indigenous materials to make it possible to live and to work. That's the way it's going to be in opening up the space frontier. I believe that's a very important conclusion of the National Commission on Space. That the other conclusion, that we're not going to do it as a one-shot, let's say, go to Mars, plant a flag, and that's that, is another very important conclusion of the Commission. It doesn't mean that we're not going to go to Mars. Sure we will. I hope that we'll be going to other places that are already out there, already places that have names attached to them as well. But it's not a one-shot kind of thing, as the Apollo project, for all of its magnificent success, was. It's going to be part of a continuing development that will open up the solar system for human beings. Now, to me, the really exciting result of that set of conclusions is that within a relatively short time, if the infrastructure that the Commission defined does start getting put into place, we are going to be free of the lockstep of a particular governmental program. Instead, people, creative individual people, small companies, startups, and so on, are going to see the opportunities which are being opened by the provision of these items of infrastructure, like a vehicle that can go from low Earth orbit to the moon and back. We're going to see the use of teleoperation. We're going to see the use of the fact, a vitally important fact, that the round-trip travel time for television and radio signals between the Earth and the moon is only less than 3 seconds. We can work at the distance of the moon without having to be there in every case ourselves. We couldn't do so if we had to go over much longer distances. So I believe that the really exciting thing is going to be, if you like, the split off from a kind of a sterile, long-defined, long-planned governmental program to something that the governments haven't planned at all, which is individual creative people opening the high frontier, using those elemental pieces of infrastructure which are going to be developed by the federal governments of the world in the course of their longer range programs. There is a relationship between science and the opening of the space frontier that I think we need to understand. Science has been carried on really since relatively early in human history, always as let's say, a 1 or 2% of the budget of whatever else was happening at the time. People's first thought is to live, eat, work, keep their families healthy and alive. They devote a tiny fraction of what they produce to opening up new scientific frontiers. The space program has been sort of backward up to the present time because it's been nothing but science and things which were done for political purposes. There isn't any production of something which is economically valuable that has come directly out of it, and I leave aside a 15-minute discussion of spin-offs and so on in the course of this. I think the really critical thing about the next phase in opening the space frontier is going to be that we're going to see the growth of actual economic productivity in space. When we do so through such things as the construction of solar power satellites, the building of space colonies which will house the workforce that will be working on valuable things in space like oxygen production, building power satellites, and so on, then we're going to see a restoration of the proper balance. We're going to see the economic activity, the feeding the people activity as being the major activity. And it will be then very, very proper and very easy to justify a strong and continuing scientific program as being the necessary advanced guard of that economic and productive activity in space. I believe that that's going to be one of the most exciting things about this next phase of space development. We as living beings on the surface of the Earth are extraordinarily lucky because there's been provided for us not just this precious surface, this biosphere that we've evolved in, but also, tantalizingly close to us, a sister planet, the Moon. There have been stories written about civilizations that grow up in planets that are far away from the nearest other place, and those civilizations tend to be very stifled in all of those stories. I think they would be. The fact that the Moon has been there, has been visible to our earliest ancestors, figures even in our body rhythms, I think is very important. Now when we come to the next phase of the development of space, it's going to be critically important. We already know from the great success of the Apollo project that it's possible for human beings to go over that distance and to return safely, even within the technological limits of the early latter half of the 20th century. But now, as we approach the end of the century, we see the Moon in what I think is properly a much more sophisticated way. We see it as a place that we can get to within just a very few days' travel time. It's a place that we can get to with people, and from where we can bring people back if they get into problems with health or something of that kind. We can bring them back to care here on the surface of the Earth. It's a place which is so close to us that it only takes radio waves less than 3 seconds to make the round trip between here and the Earth, so that teleoperation becomes a very straightforward and viable thing. I don't believe that when individual people, perhaps starting small companies or building up creative new enterprises, begin to do operations on the surface of the Moon, that they're going to be looking for ways to employ people. They're going to be trying wherever possible to find ways of doing it through observing with television and controlling with radio, with the operators sitting here on the surface of the Earth. That's the inexpensive way of starting out any sort of industrial operation, whether it's in nearby space or whether it's on the surface of the moon. The moon is a source of minerals, which we know about thanks to the Apollo project. It's very rich in oxygen. That's the most popular element in the surface soils. It's rich in silicon. It's got lots of aluminum, lots of iron, titanium, magnesium, all of the things, in fact, that we need for many of the products of an industrial civilization. We haven't proven yet that it also has organic substances there, carbon, nitrogen, and hydrogen, but it may have. And some of the most interesting science that could be done on the surface of the moon, about the surface of the moon, is to find out whether in the lunar craters at the extreme north and south poles, craters which have been shadowed for many, many millions of years, there may be an accretion of carbon and nitrogen and hydrogen ice that never melts because the sun never reaches there. We think there is an excellent chance that there are such organics on the surface of the moon. Some 20 years of scientific theoretical research indicate that there should be. And one of the programs which SSI has supported very strongly is the development of a lunar polar probe, a special spacecraft which would go into orbit above the poles of the moon, totally surveying the lunar surface in the course of every month, and looking down into those permanently shadowed craters with special and sophisticated instruments to find out if there's carbon, nitrogen, hydrogen ice there. That would be one of the most exciting scientific discoveries about the planets that we can imagine at the present time, and the one, I would say, with the greatest potential for immediate payback in terms of our development of the inner solar system. We know that the surface of the moon is easy to reach. We know that it's a place where we're going to have to try out every kind of habitat that we have in mind to locate farther out in the solar system, for example, on the surface of Mars. It's a wonderful testing ground for us. It's a wonderful source of materials. And all in all, it's the obvious next place that we have to go. People have spoken of a return to the moon, but I think that's an inappropriate kind of phraseology to use. We really weren't there before. We just came, looked around for a few days at a time, picked up some samples, and ran home again. That's not being there. When we go to the moon this time, it's really going to be, for the first time, in the sense of the products that we're going to get from it, what we're going to learn from it, and so on. So, to me, that's a very exciting, not only scientific, but industrial, technical development of the near part of the space program, and a critical element in our development of habitats in space. Because we have become so accustomed to the certainty that human civilization is going to move outward, in part, from the surface of planet Earth into habitats in space, we forget that these are ideas that were still new and strange a few years ago. And it's worth reviewing the logic why this must be so. What will space colonies be like? First of all, there's no point in going out into space if the future that we see there is a sterile future of living in tin cans. We have to be able to recreate in space habitats which are as beautiful, as Earth-like, as the loveliest parts of planet Earth. And we can do that. And the reasons come down to some very simple scientific facts. First of all, what about the source of energy in space? It's the free energy of the sun, that nuclear reactor conveniently placed for us nearly 100 million miles away. The sunlight, in the form that comes out in space, is constant, unvarying, very powerful. And when a space colony is set up in the proper way, the sun is always in the same location relative to it, so that not just in the vicinity of the Earth, but much farther out in the solar system, it's possible to have light-gathering mirrors which can produce the same solar intensity that we have here at the distance that the Earth is from the Sun. So we can provide our energy at any location that we like within the solar system, even as far out as the planet Pluto and beyond. The second thing, the second requirement for the survival and the flourishing of life, of course, is the enclosure of an atmosphere. And in enclosed habitats, one can hold an atmosphere. We know that. The important thing, though, is that from an aesthetic point of view, from the point of view of human living, those habitats have got to be big. We don't want to be living in something as small as a spaceship. And within the limitations of ordinary materials like steel and glass and aluminum, it's possible to build space habitats which are as much as miles across. Habitats that would be as large as a whole county here on the surface of the Earth. That's enough to provide green fields and forests, grass and trees and flowers and parks, the sort of surroundings that people love to live in when they're given the opportunity. So the scale of space colonies is essential to their being attractive places for the expansion of human civilization. What about growing food? Well, we know that greenhouse agriculture, that is agriculture that is under controlled conditions, grows the very best food that we have here on the surface of the Earth. And the wonderful thing about it is that growing food in controlled, enclosed environments, one doesn't have to add pesticides, insecticides, and so on, because one is keeping out the pests. There's no need, really, to import mosquitoes from the surface of the Earth. The other thing, of course, that we require in space habitats is gravity. Here we have evolved, and so have all of the other flora and fauna of planet Earth, to Earth normal gravity. We need to provide that same Earth normal gravity for the proper development of our bones and for the proper development of all of the plant and animal species. Ours is the only planet where Earth normal gravity is provided. Mars has got about half as much. Venus is uninhabitable. Mercury is even more uninhabitable in many ways. And all the others are terribly far away. But in a space habitat anywhere in the solar system or beyond, we can rotate the habitat at a slow rate to provide Earth normal gravity by the rotational gravity of centrifugal force. Newton taught us how to do that several hundred years ago, and we know exactly the speeds of rotation that are required. It doesn't even take any power. Once you set a space habitat rotating, it will rotate essentially forever. Maybe a tiny electric motor to make up for the friction losses of bearings, but that's about all you require. We do need one more thing for long-term flourishing of life in space, and that is protection from cosmic radiation. We can get that very simply by the slag, the waste products from the processing of metals and glass that we would use for building the shells of our space habitats. What is left over, all of those tons of materials that are left over, can be formed into a shield that can be set counter-rotating by just the right amount, so that overall the space colony can easily point perpetually toward the sun, the source of energy. What about the shape? The best shape of a space colony, as a result of many years of engineering research that's been done on the subject, is spherical. If you want to hold an atmosphere within a pressure vessel, a sphere is the most economical kind of pressure vessel to employ. The sphere also has some other very nice properties, among them the fact that you will have Earth normal gravity at the equator, but that within just a 15-minute walk, you can walk up to the north or south pole of the habitat and there be in zero gravity, be able to float free and to swim in the air in the same manner that the astronauts and cosmonauts do in their tiny spacecraft of the present time. There will certainly be whole new series of zero and low gravity sports that will be developed as a result of that. So everything that we need for the survival and flourishing of not just human life, but all life, can be found in space. The only hang-up that we have is that we haven't put names to those places yet. But just as we name ships, just as we name new cities, the cities of the prairies that we built back in the 19th century, we will be naming our habitats in space, and they will have names in many different languages, because those habitats in space will represent for all of us, of all nations, the room for expansion, the room for new opportunity for the people who want to move out into new environments. Many generations of the writing of science fiction stories have very interestingly failed to take account of the development of space colonies. But when one thinks beyond perhaps even the next century, if one thinks beyond to the development of human civilization, not just throughout the solar system, but to stars that are beyond the solar system, there's a very exciting result from the practical existence of space habitats. And that is that once we have proven to ourselves, as we very soon will, the right and best ways to build space habitats for our own solar system, it will be then very easy and natural to think to those stars that are nearest to us. It used to be that we considered that in order to go beyond our own solar system, we would have to find an Earth-like planet around a Sol-type star, and you might have to go 1,000 light years to do that. Well, you don't have to do that anymore, because every star that we can see in our telescopes is a source of energy. A certain amount of trimming of the spectrum just by filters is enough to give us the solar spectrum of Sol, our own sun. We know that we can make Earth normal gravity in space habitats. We know that we can enclose ordinary air, create the exact environment that we need, and around every star there are vast amounts of material, either in the form of minor satellites or of asteroid belts. There is a lot of material around every star that we see in our telescopes, aside from the double star systems, which may have soaked up most of their surrounding material. So it means that we don't have to go 1,000 light years away in order to go beyond our own solar system. Our descendants, in my guess, of as little as 100 years away, and I may be too conservative on that, are going to be starting out to the nearest star to settle human civilization around that star as well. We can see then a gradual development of humanity, and not just humanity, but of the flora and fauna that have evolved with us, to all of the stars in the near vicinity of Sol, and eventually out throughout our whole galaxy. Like all revolutionaries, when we labor to make possible the breakout to the high frontier, we can get discouraged sometimes. We have to be reminded of several things. One of them is that when people put their minds to it, they can make things happen extraordinarily fast. The whole Apollo project was not even 10 years from the start of the concept to the successful realization. Almost anything that's technically within present possibility can be done within a 10-year time span when people set their minds to it. So don't be discouraged, particularly by governmental timescales. Don't be discouraged by programs that are announced that are going to take 30 or 50 years to complete. That's the governmental program. That's not going to be the real space program of the future. The real space program of the future, the one that's going to make a difference in human history, will in part make use of some of the infrastructure developed by federal space programs, but very quickly it's going to springboard off those and use the creativity, the hard work, and the ingenuity of people exactly like yourselves, and some of you will be deeply involved in it. Second thing to remember, particularly at this time when the U.S. federal space program has been through a low spell. And when it may seem that the fundamentally right ideas of opening the high frontier are struggling for a realization, is that throughout all of human history, there has been nothing that has ever looked so absolutely rigid, so absolutely eternal as an establishment just before it's about to break apart completely. It's been true in every revolution that you can think of. Rigidity is characteristic of a system which is just about to be replaced by something better. And I think that that's going to happen in the space program because of the dedication, the hard work, the contributions, all of the ingenuity that you are bringing to it. You are the people who are going to make it happen. It really is a revolution. It's a peaceful revolution. It's a revolution for the good of everyone in the world. It's not a revolution that's going to hurt people. It's going to help them instead. It's a revolution into which we can all throw ourselves and all of our energies with full hearts. The third thing to remember in being sure to keep up our courage, keep up our guts, and continue to pour on the coal to make it all happen and make it happen on a short time scale, is that even the enthusiasts can often be far too conservative about how long things are going to take. And I think the best example of that is Konstantin Tsiolkovsky himself. You may have read his works, and you know that the pioneering work of his, the pioneering book, which described an early form of space colony, said that the human breakout from planet Earth, the very first trip of human beings out beyond planet Earth to the moon and beyond, was going to happen all right, but it was going to happen only in the year 2017. The Apollo project beat that by almost half a century. We have to keep that in mind when we realize that almost anything can be done in a 10-year period if we set our minds to it, and that even someone who is as much of a forward thinker, as much of an enthusiast as Tsiolkovsky himself, was 50 years too conservative in setting the date for the very first precursor of the human breakout into space. Think of that, and let us all be encouraged and work hard to make it happen, and happen fast.